Yeah, in this section, we are going to talk about solving systems of equations and systems of inequalities. A reminder that a system of equations or inequalities just means that we have more than one equation and we want to find the place where we have the same solution to both. And so if you look at this page, they have two equations and you can see they're both graphed and they cross at this point. And I'm going to graph it myself. And you can practice by graphing it as well. The solution to this system of equations, whether we have two or three or four equations, the solution would be the place where those lines cross. And we're only going to ever have two equations. It's the place where those lines cross each other. So there's a lot of intersections happening on this graph. Each of these lines is crossing the y-axis, and you can actually see the y-intercept for the green line. They're both also crossing the x-axis. There's an x-intercept. Those are not the solutions. The solutions are where the blue and green line, or whatever color lines you have, are crossing each other. So whatever the colors are here for your Desmos, red or purple or yellow or black, where those two lines cross is my solution. So a solution to a system of equations is always going to have two numbers, an x and a y. It's a location where they cross. So the solution for this system is 4, 2. That's my solution. Sometimes we have special cases when we have systems of equations. If the lines are parallel, that means they're never going to cross each other, and so there would be no solution. If we graph the two lines and we only end up seeing one of them, so we have two equations graphed here, but we can only see one line, that's because those two equations are exactly the same, just written differently. And so they're going to have infinitely many solutions. They're crossing always. And so we would say there are infinite solutions to that system of equations. Inequalities are similar, but slightly different. When we're solving a linear inequality, we are going to get a space that is shaded, and I will graph that one. And actually, we saw one of these in the previous video, so if it was a little confusing, I hope you asked a question. If not, I hope this clears it up. When we graph a linear inequality that has two variables, x and y, we get a line, and then we get some shaded space. And the shaded space is where our solutions exist. So any point that's in this shaded space can be a solution to this inequality. If we have a dashed line, we can't choose a point on that line to be a solution. So these points that are highlighted here are not solutions to the inequality because it's a dashed line. If it was a solid line, those points now become solutions. And anything in this purple space would be a solution to this inequality. So if you're asked to pick possible solutions to this inequality, you would pick solutions that are in the purple space. And if it was a solid line, you could pick points that are on the line. If it's not a solid line, like it originally wasn't, then you can't pick points that are on the line. You have to just pick them in the colored area. When we add in more equations and we want to solve a system of inequalities, and again, I'm going to tell you to always check that you've typed it in correctly. As you can see, it's very easy to make mistakes and type the wrong thing. So it's worth your time to always double check. You can see we have some different colored shading. One of my inequalities is shaded right here in black, and you can change the colors by clicking this. If it's not easy to see, black and red or whatever, you just want to change it. So I have some green shading. I have some red shading. And then you can see this place where they overlap and it kind of mixes the green with the red. It becomes darker, like it shows here as well. This space where they overlap, that's where I would find solutions to this system. So if I'm asked to determine, hey, which of these points can be solutions to this system of inequalities, they're going to be points that exist in that overlapped region where the green and the red go over each other and mix together to make a darker region. That's where my solutions are. So you can see on this example, the solution would be 6, -1. And then this one is also a solution because the line is solid. This one, this -2, 4 is only a solution to one of the inequalities. And this -4, 0 is not a solution because it's on a dashed line. And so therefore it can't be a solution. So just a different way that we could present this question would be to ask you to graph these and then pick where the overlap is. So we just got to get used to graphing these inequalities. And as I said before, we always want to double check or triple check, take that extra minute to make sure that you've typed this in correctly. You want to make sure that you've chosen the right inequalities, that if there's a negative in front of the 30, you type it in. And if we wanted to select the region where the solutions would be, we're selecting the region where the blue and the green on my graph overlap, the darker region. And so we would choose that spot. And actually, this is one where we would click the number of the region. For this one, we're trying to sort of work backwards. We have the graph, and we want to know which inequalities go in these, or which inequality symbols go in the inequalities. And so this is a thing where we might just test it out. So I'm going to type in everything except the inequality symbol, and then I'm going to test these inequality symbols out. So I can go down here, and I want one of these lines to look like what's on my graph. So it looks like I have, this one is the one that goes down to the right, and it needs to be shaded above it. So I'm pretty close, but this is a dashed line, and I need it to be solid. So that means I got to add the equals to. And now it looks like this one matches this line right here. So I have my inequality symbol just by taking a guess. And then I'm going to put my 2x plus 5. And then I'll put my y. And then I'm going to try another inequality symbol. I need my line to be dashed. This one's dashed, but I need my shading to be on the other side. So it's not this one. It's going to be the other one. This symbol right here, the greater than symbol. And you can see that the place where they overlap is right here, just like it is on ours. And so the symbol that I would need is this one. And I believe on this type of question, you would pick the correct symbol and you would drag it into that space. And then if you thought you were wrong, you could take it back out. One final way you might see these presented is you might actually have to graph the line. And so again, our strategy is to graph this system of inequalities into Desmos. We want to see what it looks like. Whenever you have doubts about something and you think it's able to be graphed, you should graph it and see if you can see what it looks like. And so we have two lines here. You would want to pick if the line is dashed or solid. So my blue line, or we should start with the red line. My red line is dashed, so I would be clicking this button. And then I would have to go plot 2 points on here so it would graph my line. So I could just go click this line here. There's a point. There's a point. I could graph those two. So 0, 2 and 2, 0. And then it will graph with a dashed line because I chose this option. For my second one, it needs to be a solid line. So I would click the solid line. And then I need 2 points. So I can click on this line, and I'm going to unclick those. And I have 2 points. This point is a decimal, so I might not want to use that one, but I can put 0, -2 on there. And then, oh, look, there's a point where the two lines cross, so I can put 1, 1 on there. And it would graph my line solid. So these are just different ways that they can ask you kind of the same question where they want to know, do you know what kind of line? Should it be solid or dashed? Do you know which inequality symbol matches those things? You can find all that out by looking at what it looks like by graphing on Desmos. This is the end of the second video for the second review. There are a few practice problems you should go and do. Make sure you check your answers to know that you're doing it correctly. Make sure you're asking for help if you're stuck or you didn't understand the methods or you didn't understand how you can get a greater than or less than or equals to. Take your time on these. This is the last video of this review, and good luck.